friends, today we're going to be looking at Unit 1, Day 6, the application problem. It says find 3 consecutive integers such that the sum of twice the largest and fourth power of the smallest is equal to the square of the remaining integer increased by 75. A lot of students feel overwhelmed with these type of problems. First, you got to figure out what it's talking about. 3 consecutive, that means one right after another. Integer, we know that integer means that it's going to be a number without a decimal or a fraction. That's actually really helpful because we know if we get an answer that has a decimal or a fraction, we did something wrong. So it says 3 consecutive integers. If I think about where my integers start at, if I'm going to use a variable, let's just use x. Then the next integer after x would be x plus 1. And the next one after that would be x plus 2. That's a good way to start these problems. Such that the sum of twice the largest. So if I know the largest is x plus 2, then I know that the sum of twice the largest is going to be 2 times x plus 2. And the fourth power of the smallest is x to the fourth, so plus x to the fourth, is equal to the square of the remaining integer. So the remaining integer is x plus 1 squared, increased by 75, plus 75. So again, knowing how to read this sentence mathematically and converting it from English, in this case, to math symbolically is going to help us. I'm going to go ahead and simplify the left-hand side. So that's 2x plus 4 plus x to the fourth is equal to, on this side, if I square out this x plus 1 squared, I'm going to end up with x squared plus 2x plus 1 plus 75. I'm going to combine everything over to one side. I always like to leave my highest power or exponent positive, so we're going to move everything over to the left-hand side. So x to the fourth, and then, let's see, if I have an x squared, I do have an x squared, so I'm going to minus x squared on both sides, so I'll give me a minus x squared here. Let's see, I took care of that, took care of that. If I subtract 2x from both sides, that's going to eliminate. Then it looks like I have the 76 here on this side, minus 76. So 4 minus 76 is a negative 72, equals 0. So now, this x to the fourth minus x squared minus 72, this looks very similar to our quadratics that we were talking about just a bit ago. Using u substitution as x squared, what I can end up with here is, let's see, that's going to be u squared minus u. Minus 72. Now I can factor this using the factoring properties that we know already. So let's see, that's going to be u minus 9 and then u plus 8. Set that equal to 0 and then solve. So u minus 9 equaling 0, u plus 8 equaling 0. Now if I, let's see, add 9 on both sides, I get u equals 9, subtract 8, u equals negative 8. Okay, so now I'm going to take, again, because we want to find out what x is, not what u is, we're going to take x squared and substitute it back in. So I have x squared equals 9, and x squared equals negative 8. Now, again, some foresight. I know that I am going to end up with an integer. So at this point, when I do square root, plus minus, I end up with x equals plus or minus 3 here. Now, looking at the other side, if I take the square root of that negative 8, I end up with an imaginary number. Knowing that this is an integer, it can't be an imaginary number. So this is not going to be part of my solution set. It doesn't count, because it says find 3 consecutive integers. Now if it said find 3 consecutive numbers, then I would need to count this. I don't need to in this case. A lot of students get confused. They think, oh, well, negative 3 and 3, those are the integers. No, find 3 consecutive integers. Negative 3 is one of them, 3 is one of them. So let's talk about what that means. If x equals negative 3 is one of them, that means this is 1, negative 3. If I add 1, negative 2, negative 1. That's 3 consecutive integers. My other set, 3, 4, and 5. Now, if you were to do this problem on a quiz or a test, I would recommend, if you have time, go back, double check, make sure this does work. How do you check it? Plug it back into your original equation, this one right here. If you did everything right, you should be good. In fact, in this particular problem, both of these solution sets do work. Please verify. Join the next video as we start solving the radical equations. Have a great day.